So in Python, we want to handle, usually the programs will error out if there is any error in the code. So there is a graceful way to handle these errors, or in another way, we call them as exceptions. So let's just try to create one error. Let's say I will have 1 divided by 0. This is an invalid operation. If I try to run this code, it will crash. So this is actually throwing an error called zero division error. Sometimes we will have to handle these exceptions or errors inside the code so that we can execute programs gracefully, handling all the errors. So especially in web servers, if some issue happens in the code, either due to user input, invalid user input, or due to server errors, if the server crashes, it won't recover. So it will create downtime. So in order to handle those scenarios, we will have to handle our code so that these exceptions are worked around. So let's try creating a stack trace. So this is actually giving a stack trace. This is called the stack trace of the error traceback, if you see. So if I have a function that does this, cause error, if I have this error inside a function, if I call this cause error function, and the stack trace will include which all functions have been called, which all code has been called to get into this particular error. So if I run this, now we have two stack trace items. So as long as we have this, we can debug this information. So let's say, how do we handle these errors gracefully? So it is through try and except blocks. Except. So exception is a parent class of all error types. Sorry for 1 second. So let's run this code. Try except other. Sorry, I have to call this within this try block. So where the issue is happening, that code has to be put under try catch blocks. So this is happening inside the cause error function, but the invocation happens within the try catch block. So now it is passed without crashing. If I want to see the exception type, what the error is, I can receive it as any variable. And if I try to print this in X, it will give me the error message that division by 0 error happened. So this is about exception handling. So we can have multiple exceptions handled, like except division by 0 division error. As e 0 division error. Based on the error type, we can actually have a different set of error handling code written. And with that, we will have our own custom exceptions also we can create. Let's create a new exception, custom exception. So as I mentioned, so exception is the parent class of all exceptions. We have to derive or extend this particular parent class with our custom exception class. Custom exception is a subclass of exception. I'm not passing anything or overriding any functionality of custom exception. So all the default functionality I'm using from exception itself. So how do I raise this exception is through this code cause error. Let's say I will define a function that raises this custom exception. And then let me call this cause error. Let's execute. And this has raised custom exception. So if I want to give a specific message, this is a custom exception. I can give it in this way. Any specific errors, that description will come in the exception report. So that's a way to extend existing exceptions. We can have our own n number of exceptions. Let's create a HTTP exception that extends exception. Just do a pass here. I can have n number of exceptions. I will have not found exception, which extends again this HTTP exception, and then I can have its own init function, which is the constructor. In this constructor, I need to access self. And inside this, I need to call super, which means I'm initializing. If whenever I'm overriding the constructor function, I need to call super classes constructor in order to make sure that all the variables attributes have been initialized. Yeah. So we can have any number of exceptions written, custom exceptions written, extending the functionality. Let's go through threads now. So threads are useful for parallel processing of applications and application logic. Let's just demonstrate an example. Let's say I have a function that takes a long time to complete, long square. Let's say I have a function that accepts a number and does some kind of sleep, time.sleep for 2 seconds. I have to import time module here, and then returns the numbers square. And for I will write a loop that starts from 1 to 10. In range, let's call this long square on each of these. This will definitely take more than 10 seconds because we are sleeping for every number. We are going to wait for 2 seconds and calculate the square. So this is actually to simulate an environment where large number of calculations and large amount of time takes for processing a specific application logic. So I'm just putting a sleep here so that we can demonstrate if there is a long running process or long running function, how do we make use of multi-threading? So this in a single thread, if I'm running it in one process, it's going to sequentially evaluate from 1 to 9. It's going to evaluate this square every time sleeping for 2 seconds. Let's run this code. And at the end, it will return. But let's print something here before returning print x, and let's call this. So every time, for every number that we are calculating square root square for, we are actually waiting for 2 seconds, and it takes the whole of 20 seconds to complete for all 9 elements. So this can be parallelized with using threads. So let's use multi-threading for this. So multi-threading is useful for parallel processing. So all this, if I have to calculate 1 through 10 all at once without waiting on sequentially, I can make use of threads. Import threading. Threading is a module we can use for parallel processing. Let's create threads for this. I'm going to create a thread. How do I create a thread? Is through this way. T1 variable T1 threading dot thread. Target is the method name which we want to call. Long square is the bucket, and then it also accepts an argument as a tuple. So this time I will pass 2 to the long square, and this also has to specify that this should be a tuple. So when I put a comma after 2, this actually means that I'm passing a tuple object which has only one element. If I don't have this comma, this actually means I'm passing value 2, which is an integer, and this brackets don't have any significance if I'm using around a single number. If I specify comma, that actually means that it is a tuple. So I can have like n number of arguments, but this particular long square accepts only one element or one argument. That is why I'm using only one argument, one element in the tuple. So this is creating a thread. So I'll create another thread. T2 target is same function. This time I'm going to pass 3, and T3 I'm going to pass 4. So this is only going to create a thread, but it doesn't start the thread yet. So for starting this thread, we need to call T1 dot start. For each thread, I need to call this T2 dot thread start, T3 dot start. Okay. Now this will start the threads, and it will start processing these 2, 3, 4 long squares in parallel. And we have to wait for this processors to complete. Otherwise, if the program reaches this point at line number 22, it will exit. We won't wait for these processors to complete. So when we trigger this start, it actually means that start and continue executing the next lines and next line and so on. So that's what it's an asynchronous process. It doesn't wait for the start or process to complete or this thread to complete. That's why we need to wait for explicitly for these threads to complete before exiting the program. So this is how we do it. We have to do join on these threads. Just like start, we have to do join so that we wait for the threads to complete. So this actually executes all these things in parallel. Let's try running this now. All things will execute in parallel. 2, 3, 4, all 3 got printed all at once because they all waited for 2 seconds. Otherwise, each and every thing would have waited for 2 seconds. And then one by one, it would have printed. So this is using threads to parallelly run the program, calculate many things at once. This is for multiprocessing, multi-threading. Let's try using this for like 100 threads. How do I do that for 100 threads? Let's try running this program. Let's have a threads list for t in range 1, 100. Threading. Let's use I as a variable here. Threading dot thread. I'm going to create a new thread. Target is long square. And args is the I command. And this thread, I'm going to add it to the threads list, threads dot append. So the list can have any type of data structure inside it. So I'm storing thread as the data type in these threads list. So now we have created these 100 threads and added them to this threads list. Now I have to start those and then wait for those to complete. Similarly, for t in threads, t dot start. This means for every thread that is stored in this list, I'm starting that thread. So for every thread in this list, I'm starting the thread. And similarly, for every thread in this, I have to wait for that thread to complete. So let's run this program. Python threads.py. So all 100 are going to run in parallel. So they all run in parallel. If we had taken one by one, it would have waited for 200 seconds overall. One by one, it would have done. So the time it took when we did parallelization is only 2 seconds compared to 200 seconds when we don't use parallelization using threads. And this is one type of parallelization. So how about storing the results of this particular threads output? So we'll do that later once we see how multi-processing works. This is one type of parallelization. Threading is one type of parallelization. There is something called multi-processing. Processors.py. So what happened here is within the same program or within the same process, when I'm running this threads.py, I'm actually starting a process. So if I open one more terminal and do one more time Python threads.py, we'll start another process. So these two are two different processes. So the advantage with threads is that processes do not share memory. So let's say I define the value here, let's say results as a dictionary I have. I'm also going to pass this results dictionary to this long square. I'm also going to pass results. This is going to accept one more argument called results. So after printing, I'm going to append. I'm going to add results of x number equals x. So it's also going to store this value in the results dictionary. So at the end, if I print results dictionary, it's going to have retained that results, entire results. Let's try running this for 10 entries as a sample. So this dictionary is storing the results of all the multi-processing, multi-threading. So even though we are starting these threads separately and they all have the same context object called results. So this results object is shared in memory. So this is the advantage of using threads. Threads can share the same memory space as they are within the same process. So the difference between process and the thread is that threads share same memory space. So if a variable is declared in the program, that all the threads within that program will have that access to that variable or an object. So when I have processes, two processes defined, one process cannot access the variables of another process. Even though I'm running these as separate processes, let's say process, I will create one process. So this results object, if I run two threads, this files, if I run 2 times, those two will have their own set of results objects. They cannot share the same results object because they are entirely two different processes. It doesn't share memory. So using threads, when we are using threads, it's going to run within the same process and it's going to share, all the threads are going to share the same memory space. If I declare one variable in the program or in the process, that variable is available to the entire thread collection and within that process. So now we'll see how processes differ from threads. So there is a library called multi-process in Python, which we can install with pip install multi-process. This will help us spawn multiple processes. Usually what we did right now, I can actually go ahead and create one more Python exceptions or threads that will be one process, one more terminal I can open and I can restart the same process. And those two becomes two different processes. And in this particular program, I'm going to spawn new processes within the same program. So this will be a parent process and new processes will be spawned on the fly. And we should keep note that the processes cannot share the memory. So even though we are starting new processes from within this process, even the variables within this process are not available for the other process. So if I'm declaring other process and having a variable in there, that will have a different copy of values. Let's try doing that, creating multiple processes from this program. From multi-process import process. Similar to threading, we are going to do this. Let's copy this code. I'm going to have this function. Create a new process instead of this. Let's try creating processes. This is going to be processes dot append threading.thread we are using, but we have to use process in order to create a new process. Same arguments will get passed to the same this process also. Just that we are not using threads, we are using processes instead. So this will be, let's say, P, just to differentiate that this is a process. Let's run this. Process. Oh, sorry. This is going to be P is process, and instead of process, I should use only process. Let's run. Here we are spawning multiple processes, not one single process. So there is a workaround we have to do here because of OS constraints. Main equals main. This is what we have to do. So what this name means, when I'm running this program from the console, the name of this will be equal to main. This is called a dunder, 2 underscores one after the other. So this is needed for running multiprocess in Windows. So we are spawning multiple processes here, all 10 processes together, and it's all executed. Now, if I see this print results and it's empty, so this process has declared results object as empty. And even though we are passing this to the process, it's actually going to create a new copy of this results object and pass it on to the new process. That process doesn't have the copy same reference to this results object. So these processes do not share this results object. It's a completely different copy of the object that is passed into the process. So when we have to do multiple processes that do not require shared memory, it's better to use processes. If we have to share memory, it's evident to use threads. So most of the times when we are processing server requests, it's all within the same process, which are spawned as threads. They all share the same system memory or the process memory, whereas processes, they run independently. So if I'm running independent jobs, background processes, that I can spawn with process module. If I'm running this process to simulate faster execution, we will use threads. So that's about processes and threads. Now let's look into processing files. Let's say in our operating system, we have, these are all files, right? How do I read and write files with Python? That we will take a look now. Files.py. So for reading and writing files, we just need to do open any file name. I'm giving a.txt as a file name. The second argument will be a string that represents what's the mode we want to open this file in. So this is R for read, W for write, and A for append. So if there is a file called a.txt, it will open that file in the read mode. So let's try reading this content. So whenever we open a file, we also have to close the file. So this is a standard way to read a file. Just try to print this, but there is no file called a.txt as of now. Let's try running this and see what happens. And it says file not found error. No such file or directory a.txt. So let's comment out this part. Let's say I want to write a new file called a.txt. I will do the same thing. Open a.txt with write mode. After that, f.write some text here. f.close. Let's run this file. It has created a new file called a.txt here. If I see it, some text here is printed inside the file. So let's run this program one more time. I'll have 4 more lines added. Let's run it. 1, 2, 3, 4, 5 lines. And it has 5, 1, 2, 3, 4, 5. But this has not added any backslash and characters, new lines. It's all showing up in the same line. So for adding the new line, we have to add a \n character. Whenever we add \n character, it adds a new line after the text. Let's run the same code. This time, if I open a.txt, it's all in the independent lines. So what happened to the previous line that I wrote? It got replaced by this new code, new text. So whenever we are opening a file in the write mode, it's going to replace the entire file. If I don't have this file a.txt, it will create a new file. And if it is there already, it's going to replace the entire text of that file with whatever we write here. So what if I want to append text rather than replace the entire text? So I can do that with f.f equals open a.txt. The append mode is used for appending to the end of the text. f.write some more text. I'll add \n f.close. Every time we open a file, we have to close that. Let's run this. Let's go to a.txt. Some more text got added at the end of this file rather than replacing the entire file. If I open this in write mode, let's see what happens. This entire content got replaced by this new content. So that's the difference between append and write. So let's run this code all together once. And it has written these texts here and appended this text here at the end. So now there is a shorter, whenever we open a file, we have to close that file also. So there is a shorter way to achieve this with operation, with open of a.txt, comma a as f.write some more text here. So if I do this, I don't have to do explicitly close operation. As soon as this block is completed, this file gets closed automatically by Python. Let's run this. That's all. So this is how we write files, read files. So now let's read the file. I uncomment the first line, or I'll just rewrite that code here with syntax, with open a.txt, read mode as f.read. Let's do a print. Let's run this. Read the file and printed that text over to the console. This is how we read and write to the files. And last concept that we need to discuss is the modules. Let's say I'll create a file called use module.py. Let's try running a new file. Create one more file. I'll create one more file called rhymes.py. I'll create a function is rhyme. Let's say this finds out if this is a prime number, the past prime number is a prime number or not. It's none. It's just basic code from primes equals to the 0 and power 0.5 means the square root of this number that is passed. You have to check if any of the factors within the range is exactly dividing the number or not on primes. So none else on primes. So what we are doing here is, if we had found previous prime numbers, we can divide the new number with the previous prime numbers. If it is not divisible by any of the previous prime numbers, then it is a prime number. For each factor in these prime numbers, so this modulo operation will give us the remainder of this n divided by factor. If the remainder is 0, that is exactly divisible by the factor, so it is not a prime number. So it is not a prime number. If none of them is divisible, none of the prime numbers are able to divide this number exactly, then it is a prime number. Then n is a prime number. So let's try one more function that lists all prime numbers till a maximum number. Let's have found primes equals into for n in range 2, 100. We'll calculate till 100, or as we are actually accepting that as an argument, we'll use max argument. For n in range, if is prime of n, found primes dot append, we are going to save this prime number into the list for future reference. Return found primes. This will give a list of prime numbers up to a maximum range number. This is one file. I have written one file. How do I use this file in another file? So that is demonstrated here. If I have to use one function here, I have to import this primes module or primes file. I can do it through import primes. If this is with primes.py is within the same directory, then we can use import primes directly here. From here, I can actually call the functions that are listed in the primes file. Primes.is prime of 5. I can call this function. Let's try it. Execute this use module py, and 5 is a prime number it printed. So now let's try to import a specific function list primes from this primes.py. Let's do from primes import list primes. So I can exclusively import a specific function or a variable from a Python file. So let's list the primes and list primes of 20 up to 20. Let's list primes. So it's 20. So this is one way to import another file into one file. So if I have multiple files in a package or a directory, how do I make a directory as a Python module or a library or a package? All three are one and the same. Let's create a new module or a directory called numbers. So in order to make sure that numbers is a package, I should add a special file called init.py. As long as this file is there in a file in a directory, Python will consider this directory as a package rather than a simple directory. So in this I will create one file called factors. Let's create a new function called get factors up to a number. For a particular number, what are the factors? I'll just return factor for factor in range 1, n plus 1 if n divided by factor is gives a remainder of 0. If we check this logic, I want a number that is from 1 to the number maximum number. Let's say I'm passing 5 here. So the range function gives a starting range as 1, and n plus 1 means it will give maximum number as n. So 5 if I pass here, it will go from 1 to 5. And for each of those numbers, it will divide that number divided by this 1 to 5. If n divided by 5 divided by 5 is 0, and 5 divided by 1 is 0. So 1 to 5, it will go through 5 divided by 2 will give a non-zero remainder, and so on. So if there is a non-zero remainder, it won't add it. If it is 0 remainder, then add that factor to the list, and gives the list of factors that are exactly dividing a number. So this is what the logic of prime numbers is. If the factors are only 2, the one and of n itself, if the factors of a number is 1 and itself, then that is a prime number. So that is what we are trying to find out here. So this gives us a factors. Let's create a primes.py file within this package. Let's import this numbers factors file from numbers.primes import. What's the function name? Get factors. Get factors. Print get factors of 5. Let's try running this. Numbers primes.py. No module name numbers primes. But this cannot be called directly. So if I have to write it, let's create a function called is prime of n. Let's do get factors of n if factors equals the factors of n. If length of factors is equal to 2, and return true, or else return false. So if there are only 2 factors for a number, then it is a prime. If not, it is not. So in the use module.py, let's import this numbers primes. So instead of this code, I'm going to use from numbers.primes import is prime. Length is prime of 5. Now I'm going to execute this use module. I'm going to use circular import on second times get factors. Then numbers are prime. No, we should use factors. Yes, this is wrong. We should have used numbers or factors here. Let's run this code. And that's returning true. So right now what we did in use modules is we have used this nested package, a package within the directory. So in the earlier scenario, we have just imported primes.py directly. In this case, we have imported a package, a file, and a function from a specific package called numbers package. So that's how the modules work in Python. If you go to the is prime logic, it is trying to get the factors, get factors 1 to n plus 1, which is 1 to 15. So any number is dividing 15, 3 also divides it, 5 also divides it. So that's not a prime number.
Okay.
So if the factors are only 2, so this condition checks if there is only 2 factors for a specific number. So there are like we can print the number of factors here, or we can just actually print the factors itself. Print factors. Let's run this. There are 4 factors for this. The factors are 1, 3, 5, and 15. Let's use something like 9 has 3 factors. If I use 7, so it's all mathematics and just deducting a logic from the code. So that's about the basics of Python.